Okay, my friends, this is another shocker du jour. I've been talking about this little piece that I've been finding attached to organs, muscles, and so forth that lock them in to the next body part. I call it a Spurrlock. Gee, I wonder where that came from. All right, so I named it after myself, and that's what it is right there. And that's what it is right there. And this is what it is on this rock right here. Now, I also believe this whole piece is one big Spurrlock. All right, I'm going to show you this in the microscope. I'm going to explain it to you. Let's just dive right in. Okay, what I have in here is in the scope, I have this rock here, which shows this flap. Now, this is it up in the microscope. Now, what I want you to focus in on is these two little spots here. See that little dot there? That dot right there? This is the tip that latches this thing, the Spurrlock, into the next body part so that this whole thing won't rip away. And these two dots, I'm almost sure that those are the two dots that allow the fascia fluid to go into the next body part. Because the fluid is all in here and it funnels itself down, and then right at the end it has to go into the next body part. They're connected together in one big system, and I think those are the plumbing right there. I hope you can see that. See those two dots right there? That one right there and that one right there. I believe that's it. Now, I'm not 100% sure of that, but I'm pretty sure. It has to, the fluid has to get from one to the next, one way or the other. Now, what else can we see during this shot here? Right back there is where the end of this is. All right, so right back in this area here. Hold on a second. All right, we know that the latch is coming back from the front, which is down here. And it's coming back to latch into this organ, which body part, whatever it is. Right here is where it is tough. And that is what locks it in right at that spot. All right, totally different than the rest. And that right there is where the latch starts, and it ends right here. So this piece is the piece I'm talking about. It's got cross latch. You see it? Cross latch pieces coming in, tendon pieces going sideways this way. That is a tough structure. They go sideways. They go this way. They go that way. And, well, actually, better shot to see down here. You see the sideways one? It's got sideways one, it's got going this way, they got going this way, and then it goes to a web that sprays out like that. And it's not, that white stuff. As a matter of fact, I can show it to you on, well, hold on, let me straighten out, hold on. All right, see that? That's chicken breasts. And that's the Spurrlock. That locks these together and into the body somewhere. The whole thing is locked together so it can move around and do all these kind of things it has to do. But that is where it's really locked in. Now you see this heavy duty layer here? That's the heavy duty latch that really locks it. But all of that stuff has to filter down. All of the fluids have to filter to a next body part through that little tiny bit. Now, I suppose that could be subject to a damage. I would think. Those little tiny holes there. Well, don't forget, this is what it looks like. And here's the latch. And here's that white fiber stuff here. See, there's the latch. And here's that white fibery stuff coming up. All this stuff. And you saw those little tiny two holes there. If that could be, you know, I don't think anybody knows it. Well, I know they don't know it's there. I've talked to all the, not all, but I've talked to a bunch of top anatomists. They say no, they never saw anything different. They just thought it was one big sheet of fascia that coats everything. But this is clearly not the same. And as a matter of fact, on lungs, I can show this. I have one here on the little tiny lung somewhere. Hold on, I'll find it. All right, here's another one. This is the lung that I had DNA tested, CAT scanned, all that stuff. That's the flat side, because it died laying this like this in the flood. That's the latch right there. All right, now I have to look at this one, and I think that may be the two little spots in this one, because that latch comes up around here, and you see how red and bloody it is right there? That's a whole different set of chemistry than the rest, and this is where it really locks in tight, and I think that might be those two little spots. So I'm going to put it in a microscope and see if we can find it, but I believe that's where it ends, and I think those are the two spots. But this, and they have another little spot right there at the top where it locks in, and that keeps the lung in position. It can rock around and do this and that, but it's going to come back to where that is anchored. And every part of your body has one of those. Now, the crazy thing is, I think this whole thing is one big Spurrlock, and that's the part right at the end, right here, this latch. And this is where it latches in, and this is all that gnarly stuff right at the end. So this would be like here on this, wrapping around. And you see the way it divides out? I always looked at that and I thought, what's going on with that? Why is it dividing like that? That's the latch part. This is the latch where it doubles in. And you can see, we'll look at it in a microscope, but you would expect it, if it was a membrane, to be like this everywhere. You'd have this side of the membrane, which is aluminum silicates, and this side, which is aluminum silicates, and this, which is pure silicate, which is the center of the membrane. That's what a membrane should look like. And then I saw this at the end, and I said, well, what is going on here? What is mixing in together here? And I think this is where I'm almost sure this is the top right here, the plug that snaps it together to the next piece. So whatever it was going to mate to would be under here and latched in with this. And this is ripped out. And I have another one here. I have a lung where this piece, which is this piece, would be just about like that, hanging off this lung. This one is missing. This is one that's all by itself. And I have other ones that are, like this one here, has everything is eroded, and all that's left is that little piece right there of the Spurrlock. All of the fascia is gone, and only the Spurrlock is left. You see? I don't know what kind of a lung it is. I don't think it's a human lung. I'm pretty certain it isn't. But it's some kind of lung, and it's got that latch, the same as they all have, right down on the bottom. And I have these right here. This is an iron meteorite. A meteorite means it came from space. It had to get to at least 2,700 degrees. Well, 2,200, 2,300 will form this material, which is iron. It's magnetic, which attracts magnets. And this is a lung, and this has the Spurrlock on it too. I'll show you that in a microscope. All right, it's the same, basically it's like this. And I have another one here too. It's another little iron meteorite. Tiny, tiny little one, but it's also a lung. What that came from, I don't know, but it basically looks like identical, only a child of the bigger one. All right, you see them in a microscope, you can't miss, they're lungs. And they came through space, and all the stuff coming through space has blood in it as well. I've shown that 100 times. They cut these iron meteorites in half, and you have a red spot and a black spot on them, which is our vein and artery. That's a meteorite, cut in half and etched with acid. What is this? That right there is red blood. That's from an artery. And on the other side is the black blood, which is from the vein. Whoops, hold on, you can't see that, can you? Yes, I guess you could. Right there. All these other crystal formations in the metal are different metals. A lung, or heart, or liver, which is saturated with blood, is saturated with every different type of metal there is. Blood is completely saturated with metals. Whoops, this is radiation CMOS. This is the blood. Now watch this. This is all the metals that are in blood. Every one of these is a metal. 26 elements in whole blood. They're all metals. And then there's a lot more than that. I think every single transition metal is in the blood, all the way up to uranium. They even look for uranium. It's in here, uranium. All the way up. So that's what's in the blood, and that's when they smelt, they become iron. These are organs. These are primarily hearts, lungs, and livers. And that's what they look like. When they come through, they're all blackened off and everything. See, this was small. Here's the key. How big is the thing? How hot is it going to get? The bigger it is, the hotter it gets. Now that got pretty hot and smelted pretty good. This one here is smaller. And it's not hardly smelted enough. It's magnetic, but it's not magnetic enough hardly to hold, I mean, it'll hold a little bit, but it's not really cooked. I have another one here from a bone that I'll have to find it, but it's around here somewhere. And it cooked off, and only the marrow turned into iron. So I got some blood and I got some iron in this, I got some bone and I got some iron in the same meteorite. All right, check this out. This is a bone. All right, we'll look at a microscope, but it's clearly a bone. However, inside the bone is marrow. There's the marrow. And that's magnetic. That's highly magnetic because it cooked really well and turned into iron. And these are blowouts. These little holes are blowouts from when it overheated and blew out. This, though, being the bone, it didn't last long enough to cook. So the bone is still there, almost perfectly intact as regular bone. And this is so cooked that it's turned into iron. You cannot do this. You cannot do this other than coming through space. You can't do that. The whole thing would have just charred up and burnt up. But this just overheated. Well, just believe me or don't believe me, but you show me some way you can make that happen on Earth, and I say, no, you cannot do that. It cannot happen. All right, I was going to try to do all this in one video, but it can't do justice to the extreme details. Because every one of these I have to explain in very, very clear details what it is. And this is a left hand. And again, I have to go through all the little details of it, so I'm not going to do that right now. But this is the fingertips that were on that left hand, and that's the fingernail area. And this is a 2D CAT scan. That's why it's so, I can see that clearly. And this is also a 2D CAT scan of another finger coming from the back. And that's the tendons and so forth. But anyway, again, there's so much detail that if you don't look at the detail, you can just fluff it off and, oh, that's nothing. No. And the other one, so this is one of the things I had DNA tested, and it was human mitochondrial DNA. See, I don't think Paul, the geologist, understands that, about biology. I don't think he understands biology. But anyway, this is the fingertip that was the giant fingertip, 3 feet long, that he's saying, oh, that's impossible because of this law and this cubes of this and that. Now, that's from here to the very end of the tip in the front. It's approximately 3 feet long. This is the fingernail. Now, he's claiming, oh yeah, I contaminated, no question whatsoever, so that case is closed. Well, no, Paul, it's not. I could not get any blood off of there. I could see there was no way to get it. It was absolutely flawlessly perfect. So what I did was I smashed this piece off the edge. All right, that piece right there connected right here to the fingerprint, to the fingernail. And I just went smack, and it popped right off like a scab. This is the back of it. And I want something else. I'm going to show you something else that also is just like this, which means that it adheres to a surface and is like a membrane. That's a membrane in between this skin and the flesh underneath. And I will show you to it. It's called a grip skin. So this, I also had DNA tested after I drilled down into the artery very carefully. I didn't and it was excellent quality DNA. It was just like blood. And so was the lung. This one here was a little more transitioned. It wasn't as good a quality. But the other two, he said, basically they were just like blood. And yeah, they came right out of the arteries. And this is the lung that was also tested. Right down in here, I took the sample, drilled into there, and it was basically, they're loaded with blood, they're saturated with blood. This came out of the other one, which wasn't even as well preserved, and it has blood inside. And they bubbled right out of these little holes. The blood stays very, very fluid for a very, very long time. You see that? That's my logo, and the reason I use it for my logo is because I could find just tons of fingertips and toes because they are saturated with the blood. Saturated. Same as hearts, lungs, livers. Now, this is the fingertip prints of this one here. Remember I showed you the big one with the fingernail? This was what I broke off. Let me show you what I broke off. And then this is what came off after I broke it off of the big fingertip. Because I couldn't get anything. When I looked at it, I said, well, there's nothing I can get off. It was the grip skin is thick and it's tough. And there's just no blood. So I took a big slammer and bam, and I popped this one off, and this is what came off. And it has the fingerprints and everything in it. All right, so let's look at the fingerprints and what's I call it grip skin. All right, here it is right here. This is what popped off. Now, the back of this is just like a scab. You see that? I'm going to show you something else that has that same texture to it that'll blow your mind. This is skin, grip skin, and it's keratinized, very, very dense and coarse. There's no way you get blood out of it, absolutely none. However, you get down in there, and it is completely packed with blood, packed. Now, this part here is what I want you to look at, because here's the fingerprints on this side. But on the other side here, it just popped off, just like this. I popped, and it popped right off. Now, what is this? Let me show you something. It's basically the same pattern. You see how it looks like that same sort of look? I mean, this is obviously aluminum or some kind of a metal, but there's red blood in here too, if you can see it or not. We're going to be looking at all this stuff real closely, but this is the same gluey pattern as that, and I know exactly what this is. You see? Again, there's too much to do this just like a click, click, click. But I have all the evidence here, and all of this, you know, if Paul, as being a big hotshot geologist, he wants to, you know, I've already done the DNA test, and they're very, very sophisticated. Here they were done 10 years ago almost. And there was 3 of them, 36-inch tip, the lung, and the mud tip. And the lung is this right here. And the blood came out of down here. I drilled a little pin drill into there and took the absolutely red raw blood out of there. And they did. I wanted to know, was it human? I didn't want all the fancy stuff, but he said, well, we have to do a PCR test to find out if it's human mitochondrial DNA. That's the best he could do at that time, 10 years ago. And if it came up with the sequence of stuff here, it means it's human DNA. Mitochondrial, the mother side. All right, so these are the actual codes in the DNA, which was extracted from excellent quality DNA was obtained from the 36-inch tip, the big one, and the lung. The other one was not quite as good, but it was Homo sapien mitochondrial, B gene, and D loop region. The other one was also okay, but see, these two were very dense. This one was, one of them was okay, and the other two were not as good. But they all had negative control was negative. All three of them tested, well, this one tested negative for something. But it tested positive for some of the things. Positive, positive, positive. That means it's 100% for sure. This one here was 2 positives and 1 negative, because some of the stuff will wash out. Now, this was a very, very top-end test. And like I said, it was about 10 years ago. They did a fabulous job, and he was assaulted for doing this, because all of they came after me with the big guns, let me tell you. Nobody wanted this information known. And it's still very, very unknown generally. So, again, this is just so complicated. The Spurrlock, too, is very cool. Here's another lung. All of these lungs, every lung has a Spurrlock on the corner. That's a Spurrlock right there. This little tab right here. And that's what locks this lung in position. They all have them, every one of them. Even this is a lung from I don't know what. But there's the Spurrlock on this one. You see? Right there. You see that little triangle right there? That's what locked this into position so it could go around. Now, when this died in the flood, it ended up going flat like this. That's the flat spot on this. They all have flat spots. Well, not all of them, but almost all of them. You know how flat that is? That's almost beyond flat. That's like flat, flat. Now, let me show you something else real quick. And then again, I'm gonna knock it off of this, because, like I say, I'm gonna go deep into this, because I got meteorites that are iron, little tiny iron meteorites that still have blood in them. And that's a lung, and I can show you it as a lung. I don't think anybody can contest that. And it will also have the Spurrlock on it. They do. They have the Spurrlock, that little triangle, which I'll show you in a microscope. And here's another one, little tiny iron meteorite. And it also has the Spurrlock on it. Every lung does. This lung here completely deteriorated, but the Spurrlock stays. Spurrlocks are tough. And those two little lines in there, I don't know if you can see that or not. I believe those are the carriers that carry the fluids from one fascia place to another. Here's another one. It's Spurrlocks on every one of them. This is a lung, and half of the pleura eroded away, and the other half is right down into the alveoli. Again, flat as a pancake. This was all from the flood, all from the Great Flood. These guys can laugh all they want, but it's just unbelievable that they can take that stance against the evidence and just say, no, we calculated out, this law says it's impossible. No, all these laws are ridiculous. Even the speed of light law is ridiculous. We can go faster than light, no problem whatsoever. Shown it hundreds of times. Very, very simple. The one thing I have learned from my research is that academia is just a systemic fraud. All of them. All of the people that we relied on to be truthful aren't truthful. These are the particles from Fermilab. I found those particles in our light experiments. We're using light, not using protons. They use protons. Very big mistake. Too big. We started with light right at the base of everything. And here they are, the two particles. Here they are accelerating. That's light accelerating. That's not supposed to happen. And these two particles are the smallest that CERN and Fermilab can find, and we found them. Nobody will discuss this because it interferes with their turf, with their funding, or everything else. Now, I was always taught that truth was what you're looking for. This is the acceleration of light. All these laws and all that nonsense is strictly there to keep truth suppressed. And in the case of geology and history and all that, it's to keep God denied. All right? And this was all written about it. They said this is going to happen, and the teachers are the ones who are going to do this to you. I'm not kidding you. It says it. And it also says their destruction does not sleep. False teachers. And so far, that's all I found. That's all I found. Maybe you could find some other ones, but I haven't. Anyway, I hate to keep going over and over this, but I am gonna. All right? Okay. This is going to be great. I can't wait to do this. We're going to, because this is true. They were giants. There was giants here. This guy's rubbing his feet. We think these people were just insane doing crazy things. They did things like, that's just symbolic. No. That's reality. Because I have the evidence to show it's reality. And this is from the Triassic era. The footprint pushed down, the gray clay pushed right down through the red bed, and the black cap landed right on top. The Triassic era happened over the weekend. All of this nonsense they've been printing. Not only that, look at this. That's a heart. I mean, that could be an anatomical book. They're everywhere. This stuff is everywhere. People are finding it now because they're not afraid to speak up anymore. Before, they make you feel so intimidated when you start to speak about this stuff. And comment about this, because if you have been intimidated, which you have been, I'm sure, if you start to open your mouth about this, stand up and talk for yourself. Don't let anybody put you down. This is the Spurrlock right here, and there it is right here. And I'm going to show you in all of these specimens, basically. And this, believe it or not, is just a Spurrlock. All right, this is just this piece right here. And this is the bottom, which is the glued down part. And this is up the top where the skin was. And we'll be able to see this in the microscope, the different textures. You see the texture on that? The skin glued down to that. This down here glued down to the basement layer. And all that red stuff is fleshy blood. And here, this is the bilipid layer, which is aluminum silicates. This is the aluminum, this is the silicates, which is feldspar. And everything I have basically is feldspar. And it's in different combinations of aluminum silicates, but every one of them has aluminum silicates because every one of them was coated with a membrane, 100%. Okay, my friends, I think I'm going to leave it at this for today. But I have so many things. I have literally hundreds of things to show you. And it's tough because I got to look like this here is Triassic rock. I got to show you so many details about this to support everything I say. That's going to take a while. Look at this. This is my countertops in my whole kitchen. And there's a lot of countertop here. This is the only piece of metal I can find in all of it. And I want you to look at this carefully. I did it with a microscope. That's the only piece of metal I can find. And there's about 30 feet of countertop. You see these right here? That's fascia. This was ground up. Somebody ground this all up and extracted all the metals, and that's the only little piece of metal I can find. You see it's attached to the black blood. And the whole rest of the countertop, I can't find any. And I'm telling you, there's a lot of countertop there. I couldn't find any more. I looked everywhere. Well, I didn't look everywhere, but I looked at a lot. And I looked enough to know that this is not there. But this is all ground up. You see this? This is all ground up little pieces and chunks of veins and arteries and fascia and silicates, all from something that had already sort of hardened up. And then they ground it up and they took all the metals out of it, except they missed this one little piece didn't come out. They must have put it in some kind of solution. That's all I can think. Because these pieces, this is not natural. Well, for me it is, because this could be the surface of a lung. This is what I mean. This is going to take some time to do. Like, that could be the surface of a lung, like this lung here. Where is it? All You see this here? This is what's on the surface of a lung. You see these little flaky looking things? And that holds the lung together so it can do this, and all these little flakes and stuff hold each other together. That's the bag that holds your lung. It's called pleura. And that could be what we're seeing in my countertop, but the countertops, it's this thick, and it's just made good. It's totally of this. I think they just found piles of this stuff and cut it up into slabs and sold it for countertops. That's all I can take out of this, because that's not normal. That's not, well, again, I can't say 100%. It could be lung tissue. But I would not expect to only find one little piece of metal. So I'm going to close it up for today. But we're going to go into this stuff. I got so much stuff to go over. And the microscope is going to be cooking. All right, so stay with me. We're going to be looking at toes and fingers and lungs and, just everything. Everything. And the Spurrlock will be the most important thing to understand, because that's something that's not understood in the medical industry right now. And I can very well assure you of that. I've been following how they were progressing, looking at the fascia research. I started that long ago. 2015, I wrote the paper about fascia-facilitated fossilization, the fluid-filled highway, one gigantic system. It all ties together. The skin has 50 times the silicates. I had all of that stuff all in my paper. Since then, I have found more information to understand how the fascia actually turned into aluminum silicates, which is feldspar. And again, this is going to be a long, arduous expose of the things that just literally cannot be denied. They say, oh, prove this, prove that. Yes, I can prove every single thing. And to have somebody just say, oh, that's not true, that's just not true, you're wrong, you contaminated, you did this, you did that. No, that's the kind of response you get from academia and from peer review. They will not let me publish anywhere. I am not allowed, basically I'm not allowed to even communicate with people as far as I know, because nobody communicates back. And I have evidence to support everything I say, but everything the support I have overthrows everything they say. So instead of going for truth, they go for stability. I'm sorry, just the way it is. But anyway, Mudfossil University is a place to understand truth and reality. And I'm telling you, as far as I'm concerned right now, there is going to be some kind of an eternity. If you want to base your eternity on what you've been taught, good for you. I look for myself. All right, so maybe you want to look too. We can look together. That'll be fun. All right, I love you all. We shall talk again. And stay tuned, because this is going to be as fun as it gets. All right, I'll see you all. Bye.